अरे हमें भी खेलने दो ना।
जोर लगा के हैया हो, गेम में आगे लड़के सो।
जोर लगा के हैया हो, गेम में आगे लड़के सो। पूरी पकड़ से बोले हमको भी एक मौका दो। मैदान जो भी होगा रूल रहेगा सेम। गेम बनाएगा नेम, गेम बनाएगा नेम, गेम बनाएगा नेम।
सीनियर्स में दम है पर जूनियर्स ना कम है, इनकी ये टक्कर तो फुल एटम बम है।
मैदान जो भी होगा रूल रहेगा सेम। गेम बनाएगा नेम, गेम बनाएगा।
हेलो सर, माय नेम इज
नेम छोड़, गेम दिखा।
चल
गेम बनाएगा, गेम बनाएगा, गेम बनाएगा नेम।
Welcome to MATLAB Helper's IPL prediction application for IPL 2019. MATLAB Helper is a team of experienced tutors and experts who help students, professionals, and researchers in programming and simulation. I am Vijay Aditya, who is here to help you with this video, which goes through every line of code and all the data required for this basic prediction application. This application is designed to predict the playing 11 of both the teams that are playing a particular match and the winner of all the league stage matches in IPL 2019. Bear in mind, the playing 11 of both the teams are predicted solely on the basis of their salaries. As you know, in the auctions, a player's worth is determined in terms of their salaries. It is a pretty good measure of a player's worth, but not a perfect one. Several factors can inhibit a player's selection from the playing 11. There could be personal reasons or injuries like Lasith Malinga or recently Rohit Sharma or Kane Williamson from Sunrisers Hyderabad, or national duties can prevent a player from playing for a team in IPL. Since all these are real-time factors which may take effect any number of days before a particular match, these are not considered for this prediction application. We are trying to predict the playing 11 and winner of a match solely based on the salaries and head-to-head data of two teams against each other. So the playing 11 of any team will consist of the 11 highest paid players possible with 5 bowlers, 1 wicketkeeper, and following the 4 overseas players rule. For any prediction application, data for the prediction is very important. If this data is incorrect, the prediction result will also be incorrect. If it varies slightly, it could change the prediction completely. So first, let us have a look at the data that we use for this prediction application. MATLAB Helper conducts several workshops on MATLAB and Simulink. If interested, please contact us. We begin the data segment with the schedule of IPL 2019. We can see the match number, match day, match date, the two teams that will be playing a particular match, what time they will be playing, and where they will be playing. From these, the most important data that we can derive is the two teams that will be playing a match and where they will be playing a match. Some pitches are spin favoring while the other are pace favoring. In a spin favoring pitch, we will try to have more spinners compared to pacers, and in a pace favoring pitch, we will have more pacers compared to spinners. This will affect the overall composition of the playing 11 that we select for any given match. The pitch can obviously be changed by the ground staff, but this usually doesn't happen. But we will be neglecting this and we will be considering the historical data of how the pitch is usually acting, and this will be considered in what kind of a pitch it is. This Excel contains the head-to-head data of every team playing in IPL this season. As we can see, Delhi Capitals have won against Rajasthan 7 times out of the 18 times that they have played, and Rajasthan have won 11 times of the 18 times that they have played. This gives Rajasthan a slight edge over Delhi. Rajasthan have 11 by 18 win probability, while Delhi have 7 by 18 win probability. This head-to-head ratio is used to predict who wins a certain match. This is a very simple prediction strategy to predict the winner. Cricket is a game that can change in the blink of an eye. One over, a team is cruising to victory, while the next over, they can be changed to a barely hanging scenario. On the first 5 matches this season, from a random simulation, we have predicted the playing 11 accuracy with 66.36%, while the win probability was predicted with a 60% accuracy. The data that we have considered for Delhi Capitals is that of Delhi Daredevils. The squad of Delhi Capitals is the same as Delhi Daredevils, only the name and the management have changed. So the data that we consider from here on out for Delhi Capitals will be that of Delhi Daredevils. This Excel sheet contains the squad data of all the 8 teams playing IPL. The sheet names are the team names and the data is divided into different columns. The player name, whether they are Indian or not. 0 is assigned to international players who are not Indians and 1 is for any player who is identified as an Indian. The salary is seen in crores and retained 1 is assigned to players who were retained and 0 is for players who were purchased this season or transferred into the team this season. The batting positions are of 3 types: top order, middle order, or not applicable. Top order is for players who usually play in the opening positions, 1 down or 2 down positions. Middle order is for any position between 3 down and the bottom 5 bowlers. Wicket keepers, 0 is for people who do not usually do keeping and 1 is for people who usually do keeping. Spin bowling, pace bowling and not applicable. Spin bowling is for players who do spin bowling and pace is for pacers. Not applicable is applied to every player, even part-time bowlers. Only bowlers who actually are in practice and bowl 4 overs in most matches are considered and given a bowling type. Players like Rohit Sharma and Suresh Raina have hat-tricks to their name, but they are not considered bowlers because they don't bowl regularly and are not full-time bowlers. So their bowling type will be assigned not applicable. While bowlers like Sunil Narayan, Andre Russell, they bowl regularly, although they are all-rounders, they will be given a bowling type. Let us talk about the selection strategy. We can see that any team will need a minimum of 5 bowlers to bowl 20 overs and they will need a minimum of 1 wicketkeeper in the team. We know that Kolkata Knight Riders usually play with both Dinesh Karthik and Robin Uthappa. Both of them know how to keep wickets, but both of them are also good batsmen. So these things will also be taken into account while selecting the playing 11. While selecting the bowlers, depending on the pitch, we can take 3 spinners and 2 pacers or 3 pacers and 2 spinners. Any other all-rounders that are added into the team will be due to their batting, not their bowling. We will select 5 bowlers, and if it's a spin favouring pitch, we select 3 spinners and 2 pacers, and if it's a pace favouring pitch, we select 3 pacers and 2 spinners. This way, we fill out the quota of 5 bowlers that is required. Then we go for a wicket keeper. We can see that most teams have a minimum of 3 wicket keepers. Of the 3, we select one of the wicket keepers based on their salary. We see that Dinesh Karthik is paid more than the remaining 2, so we select Dinesh Karthik as the wicket keeper. In Mumbai, we can see that Ishan Kishan is paid 6.2, while the next is Aditya Tare, who is pretty low, and then Quentin de Kock, who is paid only 2.8. So we will assume that Ishan Kishan will be keeping the wickets, while the remaining can be considered as batsmen and may or may not be in the playing 11. Done with the theory and need to prove it with simulations in MATLAB? Stuck on these simulations? For all the researchers who need assistance with MATLAB or any related simulation problem, we at MATLAB Helper offer research assistance by developing or fixing your codes in MATLAB. We have certified MATLAB experts who are eager to help you with your queries. Please visit our website and contact us for further details. In this application, instead of showing each team by their name or displaying their names in the app, we will use their flags or logos to represent them. This is easily communicable instead of reading their names every time the player uses the application. The flags of the 2 teams that play a particular match will be made visible, and another flag will be used to represent who won the particular match. All the images need to be of the same size. You do not need to worry as all the images of proper size and resolution will be available for download in the link provided in the description below. All the datasets and images will be made available there. You can download them and use them when you build the application on your own. Before we get to the code, let us see the design of the application. The components in this app can be resized and moved around as you wish. Let us see only the essential components that will definitely be required for the application. This is the label that indicates that you are in this application. This label is to indicate that this is the IPL prediction application. If you are doing something else, you can use some other label over here. This label will stay fixed and will not change or be moved throughout the running of this application. This is a smaller label that is used to represent miscellaneous information, like when this match is being held, where it is being held, what is the match number. Such information displayed over here. Now we have different buttons, axes, and tables that are used to display different data. So let us start with UI table A. UI table A is used to show the playing 11 of the team A. We will be dividing the two teams that play the match as team A and team B. For team A, the playing 11 data will be shown in UI table A, where we can see the player's name, a player's batting position, and a player's bowling style. Similarly, we have UI table B to represent the playing 11 of team B. We have UI axis B to show the flag or logo of team B. Similarly, UI axis A shows the flag or logo of team A. We have UI table A prices and UI table B prices. These two represent the amount spent by the team in crores that is segregated into categories: batsman, bowler, all-rounder, and total. We can see the amount spent in crores by the team for the batsmen in the playing 11, for the bowlers in the playing 11, and the all-rounders in playing 11. Now we have UI table here, which is used to represent and show the data of the head-to-head matches between the two teams, Team A and Team B, that are playing. We can see the total number of matches played, the matches won by Team A, matches won by Team B. This, as spoken before, will be used to predict the winner of the match. We have UI axis. This axis is used to represent the winner and their flag. We can see between Team A and Team B who won, and their flag is shown in the center. We have view table button. On clicking this button, the match data is overshadowed and you can see the IPL data, the points table at that given stage after that particular match has happened. The close table button will close the points table and you'll be able to see that particular match's data again. This is next match button. On clicking on this button, the data of that current match will be erased and you will now be able to see the data of the next match in the schedule. And the get data button is used to retrieve data that is essential for the app to run even before the first match is displayed. Want to learn MATLAB and Simulink? MATLAB Helper provides industrial training, academic training, and faculty training in both MATLAB and Simulink. Please contact us for further details. Let us begin with the code for the application. As most of you who have previously used MATLAB will know, the files that you use and execute in MATLAB at any given time are supposed to be in the current folder or properly addressed. It is a common practice to have all your files regarding one application in one folder and then properly segregated into proper folders. All the codes will be directly in the folder and different data segments will be given different folders and saved accordingly. Now we will first see about auto-generated functions. We can see that we have generated three MATLAB functions which are used to import the Excel sheets. This can be done directly with the help of MATLAB. We can directly open an Excel sheet by double-clicking on the Excel file from the current folder section when the import section will pop up. Here, the data will automatically be selected and you can change the type of data that it is going to be. The names are given the type text, numbers are given the type number, so on. Here, the batting order and bowling type are given the category type categorical. We change it to text because it is easier to compare. And once you have done these changes, you have to select the entire data range that is to be extracted. And then from the import section, you can select import data, import script, or generate function. The import data option just imports the data and saves these variables. Instead, if you click on generate function, it generates a function which gives you the entire code which can be used in any different application or script to import this particular Excel sheet's data. By default, this function has four variables passed to it: workbook file name, the sheet name, the start row, and the end row. Of these four variables that are passed, workbook file name will always change. For price and squad, the sheet name will also vary depending on which team's data we are importing. For head-to-head data and IPL schedule, there is only one sheet present, so we need not pass a sheet variable every time. We can take a default sheet number as 1 and remove the if statement assigning a default value, and you can neglect passing this variable every time. The start row for all the functions will be 2, since for every Excel sheet, the data starts from the second row. The end row will vary from sheet to sheet, and for the squad data, the end row will depend on the squad size. You can pass the squad size every time you use this function, or you can take by default the largest squad size as the end row. Using these default values, you can set them as input handlings and remove these if statements. These if statements provide values in case the passing value is missing. So you remove these if statements, it will by default take those values and extract the data that is present in those sheets, and from that row, from this starting row to this ending row. You can change the file name, that will be according to which Excel sheet you are importing. If you are importing the head-to-head data Excel sheet, you can name it as head-to-head, something of this sort. And similarly for price and squad, you can name as import squad or import schedule. Let us begin with the code that was actually written for this application. We have different properties that have been defined and used within this application. So let us begin with these properties. We have team A, team B, data A, data B, spin limit, pace limit, hedge data, schedule, match number, and points. Team A and Team B indicate the names of Team A and Team B respectively. Data A and data B are the squad data of Team A and Team B respectively. Spin limit and pace limit are the number of spinners and pacers that are selected based on the pitch. Hedge data is a historical data between any two teams which is used to select the winner of a particular match. Schedule is the variable that saves the schedule of the entire IPL. Instead of importing it every time, we save it in a variable and use it again and again. Match number indicates the match number that is currently happening, and points is used to store the points table data, and that can be used to display the points table at the end of every match. Let us see the startup function. What will be visible when we actually just run the application without writing anything else? We will use the clear command to clear out any unnecessary pop-ups from MATLAB that have already been opened. And we give the application a name, and then we turn all the unnecessary paths invisible. The UI table A, UI table B, access, the points table, all this is not assigned since we do not have the data yet. Since we do not have the data, these need not be visible and can be made invisible. So these two lines are not required for people building this application at home. These define the table vector values and the components of this points table, where we save the values initially. Initially, we define the team and the values, and these are later updated as the matches progress. Now let us see the callbacks. Let us start with the close table callback. In the close table callback, all we have to do is make the points table invisible and make the view table button visible and the close table button invisible. After this is done, we can automatically see the last matches data, and the view table button will be visible again. In the IPL prediction application close request, we just delete the app, so the app that is currently open will be closed and will no longer be visible. Now we move to view table button. In the view table button, we will be changing the miscellaneous label that we have to IPL points table based on the prediction. Here we will rearrange the table data so that the team with the highest points is at the top and the team with the lowest points is at the bottom. This need not be done every time the data is updated, since only when you want to view the table, this rearrangement needs to be done. Once this rearrangement is done, we set the variable into the points table and make this points table visible, and we make the view table button invisible and the close table button visible. Because of these changes, once the table is visible, we will have the option to close the table, and once you close the table, again you will have the option to view the table. Now let us see the get data button. In the get data button, we use the miscellaneous table to say welcome to this application, and here we import the hedge data and store it in hedge data variable. We import the schedule and store it in the schedule property. Then we make the next data button visible and the get data button invisible. We don't need the get data button anymore, since all the data that needs to be imported prior to the match data has already been imported. Let us start with the important segment of this application, the next match button. In this button, once this button is pressed, we update the match number. By default in the properties, we assign the match number value 0. And the first time we press it, it is updated to 1, and it keeps increasing every time we press this button. And once this button is pressed, you need to make the points table invisible and the close table button invisible, since the table is no longer visible, and you need to make the view table button visible. Once these changes have been made, we will be checking which pitch we will be playing in. And based on that, we will be assigning pace limit and spin limit. As spoken previously, depending on the surface of the pitch, we will be assigning the limit of spinners and pacers in the minimum 5 bowlers that we take. And if it is a spin favoring one, we have 3 spinners and 2 pacers, and if it's a pace favoring one, we will have 2 spinners and 3 pacers respectively. Once this is done, we will be moving and saving the team's names into the variables. We check which team is playing, and team A is assigned to team A property, and we assign the name using the switch statements. This is done for both the teams. Once this is done, we will be showing the match number and where it will be happening in the miscellaneous label that we have. And we will be importing the squad data and saving that in data A and data B respectively. To import the data, we will be using the auto-generated functions that we have generated previously. In this functions columns, we will see the file's name and the exact location of the file. We can see the file was inside IPL data folder within the IPL file. Hence, we give it this folder's name and then the file's name, and we also have to pass the team's name. Hence, we use the app.teama property and pass the team's name here. This extracts the data and saves it into data underscore a property for the entire applications running. The same happens for data underscore b also. Now we start with the selection of the playing 11. The first thing that we do is rearrange the data based on the salary. This is done so that we have the highest paid players at the top of the data set and the lowest paid players are at the bottom of the data set. Then after this, we rearrange it based on their bowling type. This gives the pace bowlers in the center, spin bowlers at the top, and the people who do not bowl at the bottom. Once this is done, we will be checking and running a loop throughout the data set and noting the position of all the spinners within this squad. Once these positions are noted for both the teams, we will be adding the required number of spinners from 1 to the spin limit into the playing level. And this player count variable is used throughout this application to keep count of how many players are actually added into the playing level. We will be using PXIA and PXIB variables or playing 11A, playing 11B variables to save the data of all the playing 11 players of the teams team A and team B. To add the data, we will be using player count as for the first player this will be 1 and for nth player it will be n, and the app dot data and the spinner locations and the player count value. The player count value will check and see the first highest paid spinner's location is pointed within the data A variable, and that entire data is saved into playing 11A. The same thing happens for playing 11B, and you get the required number of spinners into the playing 11 of A and B. Once this is done, we move on to the pacers. We follow a similar structure for the pacers as well, only there will be no rearrangement of the data now. Once we have saved the spinners locations, this data will be relevant and important for us at the end. Hence, we do not want to rearrange the data and disrupt this location values and make them useless. The same process repeats where we check if a person is a pacer or not, and if he is, we add him to the pacers variable, and these locations are saved. Using these locations and depending on the pace limit, we will be running a loop from spin limit to spin limit plus pace limit and adding the required number of paces into the squad. So by the end of this loop and end of this segment, both the playing 11s will have 5 players. Depending on the segregation and based on the pitch, the spinners and pacers ratio will vary, but there will be a total number of 5 players in the playing 11. Once we are done with the minimum bowler requirement, we need to satisfy the requirement of one wicketkeeper per squad. To check this, we use the same procedure and save the data of all the wicketkeepers' location in the keeper A and keeper B variables. Once this is done, we will check for the highest paid player or highest paid wicketkeeper of the squad and add him to the playing 11. A team can have more than one wicket-keeping batsman in the playing 11, and they will be considered as batsmen once a top plate keeper is added to the playing 11. This process adds one more player, and hence we have 6 players by now in our playing 11 of both the teams. Once this is done, we will be moving to the top order section. Selecting a player from now on will be tricky since a player could already be in the squad. A player could be a top order batsman and a bowler. He could be a top order batsman and a wicketkeeper. If the player is already in the squad, we cannot be adding him to the squad. So first we do the same procedure of noting all the top order batsman locations of both the teams, top A and top B. Once this is done, we will be running a different loop which checks if there is a player already in the squad with that name. We use a variable called overlap, and through the loop we check if the name overlaps between the player of the top order and a player already in the playing 11. If there is an overlap, we change the overlap value from 0 to 1, and then we check if the value is 0, only then assign the player into the playing 11. If not, we will not be assigning and we will be moving on to the next top order batsman from our top variable. and we keep running this loop until the player count reaches 9 or a minimum of 3 players are added to the playing 11. Once this happens, we will be having 9 players in the squad with 3 top order batsmen, and the wicketkeeper batsman could be a top order batsman or may not be a top order batsman. There is no limit that once a wicketkeeper is in the squad, the other wicketkeepers will not be selected into the squad. If the other wicketkeepers are paid sufficiently high enough, they might be selected into the squad depending on their salaries. And this verification and then addition is done for both the teams, Team A and Team B. By the end of this segment, we will be having 9 players in both the squads. We will be adding the remaining players from the middle order section. The middle order section contains mostly players who are not paid that high and who usually offer a bowling type. So we will be checking the middle order batsmen and adding them in the same process as the top order batsmen. We will be verifying their locations and saving them in middle A and middle B variables. And we will be using the similar verification algorithm where we use a variable called overlap and change it to 1 if there is an overlap, and if it is 0, only then add him to the playing 11. This is done, and then we add the remaining required number of players, and once the player count reaches 11, we will be breaking out of this loop. Once this is done, we will now have to check for the overseas player limit. We haven't checked for the overseas player limit as of yet, so the squad that we select could have 5 or 6 international players as well. To rectify this, we will be having a segment where we check the overseas limit and rectify the playing 11 so that only 4 overseas players are there in the playing 11 of both the teams. The overseas rule verification is fairly simple. The first thing that we do is count the number of overseas players. And if this count crosses 4, only then we need to do the rectification and removing the extra overseas players. First, we take a count of how many overseas players are present. We go from 1 to 11, where if a player is not an Indian, then we increase the count by 1. And once this count is greater than 1, we run a loop from the first to the current number of overseas players in the loop and check if the previous value is greater than the current value, or the previous player's salary is greater than your salary, then that player is moved to the top of the list and you are moved to the bottom of the list. So we remove the bottom players from the list and we replace them with Indian players and leave only 4 players in this list. Once this is done, we can use this overseas positions for both the teams to remove the extra overseas players. So now we have the entire loop devoted to noting the positions and arranging the positions in the ascending order of their salaries. The same loop can be used for identification of players, overseas players in Team B as well. Once this is done, we move to the segment where we replace the overseas players and add Indian players instead of them. The addition process is not that simple. First, we note the position of the player and check which position he is in. If the player is within the spin limit, then he was selected as a spinner. If he is in between the spin limit and the pace limit, then he was selected as a pace bowler. If he is between the wicketkeeper's 6th position and the top order's end 9th position, he was selected as a top order batsman. If he was in the exactly 6th position, he was selected as a wicketkeeper. If he was beyond 9th position, he was selected as a middle order batsman. Using this data, we will be checking the position of the overseas players who are paid the least and then replacing them with players of the same section. If he was selected as a spinner, then we check for other spinners who are paid lesser than him but the highest in the list according to their salaries, and then we verify if he's already in the playing 11 or not. If he's not in the playing 11 and he's an Indian, only then we add a player to the playing 11 instead of the overseas player that was currently in the playing 11. Once this process is done for all the players that are beyond the overseas players limit, we will have a proper playing 11 which follows the 5 minimum bowlers rule, 1 wicketkeeper rule and 4 overseas players rule. This process is repeated for both the teams. So now we will have a proper playing 11 for both the teams. Once this is done, we will have to display the data. So we will assign a new variable called final A and final B where we add the data that is required to be displayed to the variable. We only need the player name, their batting position and their bowling type. So of all the data variables that are available in PXIA, we only take player name, batting and bowling types, and similar process is repeated for team B, and we set them using the set function and make those tables visible so that we can see the playing 11 of both the teams in the application. Once we are done with the playing 11, we will have to display the flags of the teams. For that, we will use imshow and imread functions where we will address the function to the images folder and the team name.jpg. For CSK, we will be showing images/csk.jpg. You'll have to save them in the images folder within the folder of this application, and the team's name should be used exactly as we are saving this variable, and it will have to address the axis that you want to display the flag to. For team A, we use UI axis A, and for team B, we use UI axis B. After this, we will also have tables to display the cost. For cost, we have different categories: batsman, bowler, all-rounder, and total cost. And then we run a loop from 1 to 11, checking if a person is only a batsman, only a bowler, or an all-rounder. If he's not a batsman, that counts him as a bowler, and then we add his cost to the cost of a bowler. If a player's batting position is described as not applicable, then he is considered as a bowler. If a player's bowling style is not applicable, then he is considered as a batsman. If he is not in both of these categories and he has both of them as some or the other value, then he will be considered as an all-rounder and his cost will be added to the all-rounder section. Every player's cost will also be added to the total cost section. This process is done for both the teams, and then we set these values using the set function to different tables that we are using to represent this data. Once this is done, we will also have to verify and predict who will win a particular match. We use HH data variable and we save the data of both the teams. We will use the HH variable to calculate the probabilities of both the teams. In the HH data, in the matches segment, we will be saving how many matches were played by team A and team B against each other. Then we'll also save the matches that were won by A and the matches that were won by B. Once this is done, we will be assigning the table and we will be setting the table to be visible. Once this is done, we will be finding out the probability of Team A's victory and Team B's victory. Team A's victory will be defined by the formula matches won by A divided by matches won by A plus matches won by B. The total number of matches played between the two could also have been abandoned due to rain or several other factors. Because of this, we will not be considering the total number of matches played by the two as the denominator. We will be considering as the matches won by A plus the matches won by B as the denominator. Since there is a super over chance, draw is not an option in IPL league stages either. So only a matches abandoned by rain will be counted as a tie. So now once these probabilities are defined, we will be using random selection function, which is a function that is present in MATLAB to select between 1 and 2 with the probability weights assigned. Once this is done, if the result is selected as 1, we assign the winner as team A, and if the result is 2, we assign the winner as team B. Once this is done, we will be using the same imshow imread function to display the flag or the logo of the winning team. Post this, we will also have to update the points table and add points to the winning team and keep the points as it is, but add a match as has been played and lost by the losing team. This is done in this loop where we run from 1 to 8 and check if the winning team is team A or team B. If it is team A, then we add 1 point to their played and 1 point to the 1 and 2 points to the points table. If it is not and they have lost, then we add 1 point to played and 1 point to lost. Once this is done, we can make this table visible and now we can see the entire function and it is running. Now that we have seen the entire code, let us run this application and see how it works. Parva is an interactive learning environment based on inverted classroom methodology aimed at providing important insights into some of the key STEM concepts taught in high school and engineering courses. Parva is an application-oriented learning environment which focuses on teaching students with play and learn method. This game-based methodology is hoped to achieve higher retentivity and understandability of concepts. Moreover, this application aims to not only assist students in better understanding key scientific concepts, but also assist teachers and faculty in explaining such concepts in an interactive manner. Now let us get back to the IPL application and see its execution. An application can be run by simply clicking on the Run option available in the app builder. Once the app opens up, first, according to what we have built, we click on the Get Data button. The MATLAB imports the data, and when it is ready, it will display the next match button. Let's start the prediction, and when we click on the next match button, we should get the first match's data. See, the first match was between Chennai and Royal Challengers Bangalore. The prediction was Bangalore will win, but we know that Chennai has won. We can see the playing 11 of both the teams, and since one match is over, we can now see the points table and what the current position is. Since the prediction was RCB would win, RCB would be in the top position, and Chennai have played one and lost it. Since we are not considering net run rate, the points table will not be sending them to the bottom of the table, it will be somewhere in the center. Now we go to the next match where we can see the match is between Kolkata Knight Riders and Sunrisers Hyderabad. We can see that it is rightfully predicted that Kolkata Knight Riders would win the match, and we can see the playing 11 also. And again, we can see the points table where we see RCB and Kolkata at the top of the table, with Chennai and Sunrisers both having lost one match are still at 0 points, and remaining four teams who haven't played a single match at 0. This will keep continuing until you reach the end of the league stage. Now let us verify the accuracy of this prediction application. This Excel sheet contains the accuracy rates of all the matches that have happened until the recording of this video. We can see 0 indicating that a match winner was predicted properly and 1 indicating the match winner was predicted improperly. We can see that the match winning was predicted with a 43.47% accuracy, which is not high. But this value varies with each simulation since we let the computer decide based on the probability weights that we have assigned. But the playing 11 that we predict is a fixed one and does not vary from simulation to simulation, where we can see the maximum error in the playing 11 of one side has 7 as the maximum error out of the 11 possible, which is almost 60%. And the total player errors, the highest being 11, which is 50%. So in any particular match, out of the 22 players that are selected by both the teams to play, we have never predicted with more than 50% error. We can see the total accuracy rate is 62.845%, which is a significant amount considering we have not taken into account several factors which inhibit a lot of players from selection and which modify the playing 11 that happen in real time. Without considering all these factors, just considering the salary, we have a pretty decent accuracy rate. Thank you for watching this video. If you liked it, please share, comment and subscribe.